Hi again, and thank you so much for continuing with me on this journey through the CLEP College Algebra series. Now we are going to cover absolute value equations and inequalities. Okay, so we've already talked about equations and we've talked about inequalities. We talked about the relationship between equations and equality. Now we're going to go ahead and relate that to absolute values and equations and inequality. Okay, let me go ahead and do a few things here. Okay, before we can do that, we need to understand what an absolute value is. So let's go ahead and talk about absolute values. Absolute values make things positive. For example, if you have the absolute value of 2, it's just a positive version of 2. Well, 2 is positive, absolute value of 2 is 2. Absolute value of negative 2 equals 2. Okay, so as you can see, for 2, there are two answers to absolute, two things that make a positive, that make a 2 for an absolute value. A positive 2 and a negative 2. Two things make a 7 for absolute value of 7 and absolute value of negative 7. So for any number, there's two possibilities when you're looking at what makes that number. There's a positive version of the absolute value of positive 10 is 10, and the absolute value of negative 10 is 10. And that's kind of the mind frame we want to be when we're solving absolute value equations and inequality. Okay, so 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 absolute value of x for any number is gonna be two things. It's gonna be the negative of that number and the negative of x or negative x. Um, don't need to write that number. We're calling that number x. So negative x and positive x. Okay. So now if you have an absolute value problem, so let's do a basic absolute value problem. The absolute value of x plus 3 is equal to 10. Okay, what you want to do is step one, you want to split your problem. Split it into two different problems. X plus 3 equals the positive 10, just like you have. And then do another part of it, but this time you want to represent the negative. So one is going to be positive, one is going to be negative, and you go ahead and eliminate that absolute value. And then solve this like you would any problem. Subtract 3 on both sides. Okay, so x is equal to 7, and then subtract 3 on both sides here. So x is equal to negative 13. So it turns out there are two things that if you add 3 and then find the absolute value, you're going to get 10. So you can always check this. 7 plus 3 absolute value, is that going to be equal to 10? Well, 7 plus 3 is 10. Absolute value of 10 is equal to 10. Okay, and check the second solution. Negative 13 plus x plus 3, is that going to be equal to 10? Okay, well, negative 13 plus 3 is negative 10, so absolute value of negative 10 is 10, so our solutions are correct. Okay, so we have two solutions. If we want to see it in the number line, x is at 7 and x is at negative 13. Okay, so 2.7 and negative 13, if you add 3 to them, you will get, and find the absolute value, you will get 10. Okay, so now what if you have something like this? Okay, so let's say you have a problem where it's like the absolute value of some number x plus 5 equals 6. Okay, well here, what you want to do first is look on your side of absolute value. Look on your side where you have absolute value, and you want to isolate the absolute value. So you always want to, before you can split it up, you always want to isolate, get it by itself, the absolute value. Okay? Okay, I'm sitting outside today, and there are lots of noise associated with being outside. Okay, so before you do anything, isolate the absolute value. So what I mean by that is you want to get the absolute value by itself. I got to get rid of plus 5 to get the absolute value by itself. So subtract 5 on both sides. Do the opposite operation of adding 5. Okay, so this becomes 0. So you just have the absolute value of x is equal to 1. And now that you have isolated the absolute value, you can split your problem. Okay, so now x is equal to 7 and x is equal to negative 1. That is a 1 and not a 7. Okay, 6 minus 5 is 1. I wrote it like a 7, so made it look like a 7. 1. X is 1, x equals negative 1. Okay, so step 1, split your absolute value. Step 2, isolate your absolute value, split your absolute value. And then step 3, I want you to solve. Okay? So let's do another one. Let's say you have 2 absolute value x plus 3 plus 7 is equal to, let's call that 15. Okay? Step 1, go ahead and isolate your absolute value. So 1, isolate. So that means this is my variable, this is my important stuff right now. I want to get rid of everything that's keeping that from being by itself. Okay, so you have a times 2 and a plus 7. We want to get rid of a plus 7 first. Okay, so 2 absolute value x plus 3. You want to get rid of a plus 7 by subtracting 7 on both sides. I'm making some mistake. Do the inverse operation. 7 minus 7 is 0. 15 minus 7 is 8. Okay, step 2. You want to get rid of 2 because now 2 is being multiplied to the absolute value. You get rid of a multiply by 2 by dividing both sides by 2. Okay, so now your absolute value is isolated. Absolute value of 3 is equal to 4. Now that the absolute value is isolated, now you want to split. Okay, make this into 2 problems. Alright, so now you have x plus 3 is equal to 4 and x plus 3 is equal to negative 4. Notice, students make a lot of mistakes on this. The only sign I change is the equal to sign. Okay, I do not change the sign inside the absolute value. The only sign I change is the equal to sign. Okay, so equal 4 and equal negative 4. Now solve for the x. Subtract 3 on both sides. So x is equal to 1. Subtract 3 on both sides. So x is equal to negative 7. So the two solutions that you add 3, add 3, get the absolute value, and multiply by 2 to give you 15 will be 1 and negative 7. Okay, and I'll let you go ahead and check that on your own. Okay, and then solve. So isolate, split, solve. Alright, so let's go ahead and talk about inequalities. So inequalities are similar to equations just like before, except for when you divide or you multiply by a negative, you switch your inequality sign. So let's go ahead and look at absolute value inequality. Inequalities. Okay, I'm going to go ahead and use that shortcut for inequalities. Alright, so let's say you have the absolute value x plus 4 is greater than 3. Okay, so step 1, step 1 is to isolate. Okay, on this problem, we don't need to isolate because the absolute value is already isolated. So step 2 would be to split. Okay, so let's see how this differs from equal sign. So what you want to do is x plus 4 is greater than 3 and x plus 4 is less than a negative 3. So there's the difference. Here you keep your greater than sign, but when you do the other one, you want to flip the inequality sign. So you change the sign and you flip the inequality sign. Okay, and then you solve. Minus 4, x is greater than -1, minus 4, x is less than -7. Okay, and you're going to need to graph some of these. Okay, so let's go ahead and look at what the graph looks like. -7 is on the left here, and -1 is after the -7. Okay, it's actually numeric. If you're looking from left to right, it's after, but numerically, it's before, closer to positive. All right, so greater than -1. -1 is not included, so you make a hole. Okay, it's a circle. No, it's not shaded in. And greater than means it's going towards to positive. Less than 7, you make a hole, and it's going towards the negative. So it turns out that this is an or statement. It's either going to be going from -7 away from the -1, and then from -1 to the right. So from -7 to the left, or from -1 to the right. Okay, so this is an or statement, and I'll tell you how you will know. Okay, that is it gonna be an and or an or without actually having to graph it. So this is solve. Okay, again, the difference between the equations and the inequality here, in addition to whenever you're multiplying and dividing by a negative, you flip the sign. Now when you split it, you're gonna flip the sign of the negative side. Okay, now let's do another one. Okay, so what if we have one where you have to isolate? Okay, so let's say absolute value of x, 2x minus 5. Okay, absolute value of 2x minus 5 divided by 2, -2, is less than -3. Okay, so let's go ahead and move that over. Okay. Okay, so what if we have, let's say we had 2x plus 1 absolute value divided by -3, okay, is greater than or equal to -1. Okay, step 1. What you want to do is you want to go ahead and isolate the absolute value. Okay, so first I want to get rid of this -3 in the denominator. Okay, so I want to multiply it. So your goal here is to isolate the absolute value. Okay, multiply both sides by -3. Notice this is an inequality. I am multiplying both sides by -3. 3 over 3 is 1, which cancels out because 1 times anything is that number. So you just have the absolute value of 2x plus 1, okay, is less than or equal to 3. Okay, do you see why I did less than or equal to 3? You should, because you are multiplying both sides by -3, so your absolute value sign changes. Okay, so that's the first thing you should notice. So isolate the absolute value. Okay, and then now that it's isolated, you want to split, then solve. Okay, so now I'm gonna split my absolute value. 2x plus 1 is less than or equal to 3. 2x plus 1 is greater than or equal to -3. Alright, now you solve. -1 on both sides. -1 on both sides. So 2x is less than or equal to 2. So your variable, by dividing by 2, you realize that one of it, x, has to be less than or equal to 1. And on this one, subtract 1, 2x is greater than or equal to negative 4. 2x is greater than or equal to negative 4. Divide both sides by 2. So your variable x is greater than or equal to negative 2. Okay, so this is negative 1. That's greater than negative 2. And again, started out with a greater than. This is on 1. This is on negative 2. Okay, this is now included. Greater than negative 2. So greater than on negative 2. And this one is less than on 1. So less than on 1. Notice how those connect right there. So it goes from here to here to here to here. That means that this is an AND statement. Okay? And when it's an AND statement, you can combine it by looking at the graph. This is a 1. By looking at the graph, you can see that this means that your variable has to be a number between negative 2 and positive 1. So we have to write that your variable is a number between and included negative 2, the smaller number comes first, and 1. Okay, so that's that. Well, what if you say, well, this is greater than, how come it's a less than right here? Well, notice how the x is flipped. So this reads, you have to read it from the x. X is greater than negative 2. See how you're reading it backwards. And then you have to read it from the x for the other one. X is less than 1. So it's actually saying the same thing. It's just that now we're just reading it backwards. Okay? Alright. So how do we know if it's an AND statement or an OR statement? That is a good question. So let's look at that. Okay, so AND versus OR. AND, meaning that they connect, versus OR, meaning that they go opposite ways. Okay? How do we know if they're going to connect or if they're going to go opposite way? Okay, once you isolate, so you're looking at the isolated absolute value. Okay? Value. Once the absolute value is isolated, okay, once it's isolated, if you have a less than or a less than or equal to sign, then you're going to have an AND statement. Okay? If you have, once the absolute value is isolated, and you have a greater than statement, then this will be an OR statement. Okay, so that's something that you need to memorize. Okay, this is something I put learn. I don't like the word memorize, I like the word learn, which means you're going to do lots of examples, you're going to understand why, so that you can remember it in high-risk situations like a test. Okay, so AND statement, you want to look at it once it's isolated. If it's less than once it's isolated, then it's an AND statement. If it is greater than once it's isolated, then it would be an OR statement. Okay, so here is an example of what I mean by isolated. Okay, this is an example of something that would be an AND statement because it's isolated versus, so this is isolated because the absolute value is by itself. There's nothing keeping the absolute value on the left side. As opposed to this guy, x plus 3, absolute value minus 7 is greater than 3. This is not isolated because the absolute value is sharing the space with the negative 7 on the left side. Okay, so that's important. Another thing that's important is there are some special cases. Okay, and I want you to be able to recognize these special cases because you're going to make sense of them. Okay, first things first. Can an absolute value be negative? Okay, the answer should be no. Absolute values are by definition positive. They're like distance. They're real. They are not negative. Okay, so they can never be negative. So if you have a problem like this, absolute value of x plus 3 is equal to a negative number, okay, the answer here is no solution. Okay, absolute values cannot be negative. Okay, so this is an example of negative, of no solution. This is no solution because of this negative after an equal sign. Absolute values cannot be negative. No solution. All right, what if you have the absolute value of 3 is less than a negative number? Again, this is a no solution. Once it's isolated, you always want to look at these once the absolute value is isolated. So this is for isolated absolute values. Okay, so they might trick you by putting a bunch of stuff where once you isolate it, it doesn't have the negative. So you want to make sure that it's already isolated. Absolute values cannot be negative, so a question like this, because it's a negative, is a no solution. Another one, if you say the absolute value of something is less than 0, that doesn't make sense, again, because less than 0 implies that it's negative, so that's a no solution. That is not possible. Okay, so what if you have another one? This is a funny special case that you should always recognize and know before you even try to do it. What if you have absolute value x plus 5 is greater than a negative number? Okay, when you see that, you should be like, duh, of course it is. Absolute value is positive. Positive numbers are always greater than negative numbers, so this is all real number solution. This will always be true. Okay, so this will be always true because it's a duh statement. You don't have to do any work on this. Okay, it's a duh statement. Of course, absolute value is greater than a negative. Are you trying to mess with my mind here? So those are the special cases that I would like for you to recognize, and because those will help you from either doing too much work or they will save you from making mistakes. Thank you again for paying attention and being with me on this series. I'm really enjoying it, and I hope that you are enjoying it as well.